In this video, I'm going to show you how to set up links. If you don't know what a link is, view the links introduction video, and it'll give you some examples of how links are used. In this video, I'm going to assume you already know how to develop Reaction Plan Manager++ solutions and focus our attention specifically on links. So what is a link? A link is a mechanism that's attached to a dimension item. Links are made up of triggers and actions. As data flows into the dimension item, the triggers determine when the actions actually execute. Triggers are rule violations, so you can set up different combinations of triggers that'll execute actions. So for example, if a percent of tolerance or out of tolerance condition occurs, you may want to execute these actions. The actions are a series of equations that yield some sort of results. I'm going to design a link that monitors the tool 1 dimension item. If the percent of tolerance or out of tolerance condition occurs, I want to trigger the execution of the link. The actions that I want to take place is I want to take the correction amount and apply that as a process shift to tool 2. The link button here will let me work on the links. So I'll click on that button and it will bring up the links window. Remember, there are three pieces to a link. You have the dimension item that you're monitoring, or the dimension item that's attached to. You have the trigger properties and the actions. So to add a link, you just simply pick the dimension item you want to attach the link to. So here I'm going to attach the link to tool 1. I just added a link. If I click on the tool 1 dimension item, you'll notice down here you have the tool 1 link properties. Here is where I'll define or set up the triggers and the actions. I want to design this link so it only executes if there is a percent of tolerance rule violation or an out of tolerance rule violation. So I'll check those two fields in my triggers list. Now I need to set up the actions. I'll click on the Actions tab, and here you'll notice you have an equation builder. Here is where you'll set up the equations to actually do whatever calculation you need to do. In this case, we're going to build the correction amount to be a process shift to the tool 2 dimension item. When I build an equation, I usually start with the type of equation that I want to set up. Here you have a drop-down list that has a list of different equation types. You can do simple math, trig functions, variety of different things you can do with the equations. In this example, this is just a simple assignment statement because I want to take whatever the correction amount is from tool 1 and I want to apply that to tool 2. So it's a simple assignment statement. So the results, I want the results to go to a dimension, and I want that to go to tool 2, and I want it to go as a process shift. So when I execute this equation, it's going to be an assignment statement, and the results are going to go to the tool 2 dimension as a process shift. So on the right side of the equal sign, I need to tell it what data I want to copy, or I should say share, from tool 1 dimension. And here I want to use the last run correction amount. So when I fill this out, I'll click on Add New, and I'll add that equation to this link. You can see below the equation. Here you can see dimension tool 1 last run correction is going to be equal to dimension tool 2 process shift when this link executes from these triggers. So our link is complete. Let's go ahead and say OK to this. Go to the view mode, save this solution, and let's actually run some parts to see what happens. While parts are being measured, the link associated with tool 1 was monitoring the data flowing into the tool 1 dimension item. When the percent of tolerance rule violation occurred, that triggered the execution of the actions of the link. The actions took the correction amount of tool 1 and applied it as a process shift to tool 2. Here you can see tool 2 has this little faded triangle or diamond, whatever you want to call it. That represents the process shift. The process shift is used to figure out what the correction amount is to determine if adjustments are required. So you can see we're in spec, however it's telling us to make an adjustment. That's because the correction is the accumulation of the actual deviation from nominal and the process shift. So that yield a correction of 0.0049, where you can see our deviation from nominal is 0.006, but our process shift is minus 0.0055. So if you add the two together, you get 0.0049, which is the amount that it's telling us to correct our process. You now understand how to design and implement a link. In our example, we linked tool 1 to tool 2. Tool 2 used the correction amount of tool 1 as a process shift. Well, what happens if our application is a little more complicated and we have a tool 3 dimension item? And let's assume tool 3 needs to be linked to tool 1, and instead of using the correction amount, we want to use half of the correction amount of tool 1 as a process shift for tool 3. So what I want to show you now is how to set up that example. Let's go to the edit mode and add a tool 3 dimension item. I'll click on the edit button and I'll just insert another dimension, and I'll fill out the properties for this dimension item. We'll call this tool 3. No adjustments required. For the dimension, we'll pick another X dimension. We'll pick the dimension 4X. For the last one, corrections, we'll set the percent of tolerance criteria so it's 80%. Put in a message. Do the same thing for our out of tolerance condition. Now you should understand, you should know how to set all this up from watching the other videos. Alright, so we've added tool 3. Now it's time to work on the link to support the process shift from tool 1 to tool 3. We already have a link that monitors the tool 1 dimension item. So all we really need to do is modify that link and add another action to the link that will give us a process shift for the tool 3. So let's go ahead and click on the links button. We'll click on the link itself and we'll go to the actions, and here's where I need to add the appropriate action that will take the correction value of tool 1, divide it in half, and apply it to tool 3 as a process shift. When I build my equation, I don't want to do an assignment statement. I actually want to do a mathematical expression. I want to do a multiplication equation. Notice when I click on multiply, I've got a variable times a variable. So what I want to do is set this up so that it's going to take the last run correction of tool 1 and divide it by, or I'm sorry, multiply it by a user value of 0.5. So this will take care of the equation for me. I'll multiply the last run correction times 0.5. And the results, I want it to go to tool 3 process shift. So when the percent of tolerance rule violation occurs or the out of tolerance rule violation occurs, not only will it do the tool 2 process shift, but now it'll also do the tool 3 process shift. My link is complete. I'll say OK, and now it's time to test the link. Let's go to the view mode, save the solution, and measure another part, and let's see what happens. So I measured another part, the link executed, the tool 2 dimension item updated itself as expected, and tool 3 also has a process shift as well. Notice the process shift for tool 3 is minus 0.0027, which is half of the correction amount of minus 0.0054. So our link worked. So you can see links can be much more complicated and more sophisticated. It just depends on what your requirements are and what type of mathematical expressions you need to do to satisfy the requirements. So far, we've only required one link to satisfy our application requirements. Well, what if tool 3 is not linked to tool 1, however it's linked to tool 2? What would that look like? How would we set up our links to satisfy that requirement where tool 3 is really using the correction amount from tool 2? Let's go back to the edit mode and pull up the links menu so we can design the links accordingly. Right off the bat, we need to alter tool 1, the tool 1 link. We need to get rid of the action that actually does the link to tool 3. So we'll delete that. And we need to add another link to tool 2. Now, when the links execute, they will execute in the order in which they appear here. So it's important that you maintain the appropriate order. Tool 1 needs to execute first, then we want tool 2 to execute. We'll set up our triggers accordingly. And now for our actions, I want to do a process shift to tool 3. Instead of doing a multiplication, I'm just going to do an assignment statement and assign the last run correction of tool 2. Now, when this executes, tool 2 is being monitored. So tool 1 may affect the events for tool 2. And when tool 2 executes, the link executes, it will update tool 3. So tool 3 is really could possibly be an accumulation of the adjustments made for tool 1 and tool 2. So let's go back to the view mode and test this design and see what it looks like. Let's measure another part and let's see what happens. The tool 1 link was triggered because of the out of tolerance condition. It gave us a process shift of -0.0071, which in turn triggered the tool 2 link, which gave the tool 3 process shift of 0.0065. So the 0.0065 is really an accumulation of the tool 1 adjustment as well as the tool 2 adjustment. In this video, you learned how to design and build links. The type of links we used resulted in process shifts, which are a pretty common application. I encourage you to visit our website to view more videos that will highlight some more capabilities that exist when using the links feature.